one is that the lunch is cancelled because you need to hear my presentation, and the second thing is, no, I'm joking. The second thing is that I am going to drop quite many slides because in the interest of time. So first I was looking into what is nearly zero, what does the definition contain in different European countries. And that is actually quite a varied situation, simply because there's no consistency between different countries. So in Bulgaria you have that it's less than 88 kilowatt-hours per square meter per year, plus 55% of renewables, and you can see the variation. So there's no consistency in what nearly zero energy is. We used to call this in the UK low carbon buildings, and I used to joke with my colleagues to say low carbon is really just coal in the ground. It's very low in the ground, but we really need to do zero carbon. So steps towards energy retrofit of nearly zero carbon sports buildings is to establish the energy performance of the building, and then to establish resources to finance the renovation, then to develop action plan, and then to carry out measurement and verification of energy savings. And in terms of the action plan, there's a staggered approach. First, a typical building needs to be evaluated, and adequate use and maintenance of energy needs to be established, and then energy efficiency measures need to be introduced, and then renewable energy needs to be introduced until we achieve nearly zero energy building. These are just some of the measures: building envelope solutions, windows and shading solutions, energy generation and thermal storage, lighting solutions, efficient motors and pumps, ventilation solutions, building automation and renewable energy. And in terms of specific measures for swimming pools, there are pool covers, the heat recovery from pool backwash water, and high energy efficient pool dehumidifiers. And in terms of specific measures for ice rinks, there are refrigeration system solutions and low emissivity ceilings and so on. The measurement and verification of energy savings is introduced using this formula according to efficiency valuation organization, and the reference is there. And I'm just going to give you one example. This is Sleaford Leisure Centre in the UK. It was constructed first in 1886. It was updated in 1981. And it was seeing falling visitor numbers, and in 2015 £2.9 million was invested in redeveloping the facility and incorporating a range of sustainability measures. And one of the key factors in this was that it was connected to district heating using straw bales, which were sourced within 50 miles radius, and that district heating system also contributed to electricity supply for 65,000 homes, and excess heat was provided to 5 public and community buildings in the center of the town. So this is a combined heat and power. And in terms of lighting, LED lighting was introduced, and pool tank was insulated, and there was a refurbishment of the original bell filters for electricity supply. So from 1886 to 1981 to 2015, this is what the facility looked like. And the new facility was achieved with 50% of the cost of a new center. So 50% of a new center would have cost 50% more. And they saw 60% increase in visitors. And you can get more information about this from Sports England website on Sustainable Clubs UK. I'm going to skip the next one. Only to say that it seems to me that retrofit to nearly zero energy does not go far enough. Steps towards sustainable net energy buildings need to be more structured. And I'm going to give you an example of my own methods to sustainable net zero energy buildings. First, there are several steps there. First, conduct instrumental monitoring of the existing building to establish the baseline, create dynamic simulation model, calibrate simulation model with data from monitoring, measure building physics properties by running simulation of dynamic heating tests, take the calibrated model into the next stage of design for deep energy renovation, and then conduct multi-objective optimization until a recipe for not just net zero energy but zero energy is achieved. And then carry out quality control of renovation by calibrating simulation model and measuring building physics properties by simulating dynamic heating tests. So for measurement of performance before and after, you would have a weather station, you would have a range of sensors, temperature and humidity sensors, and energy consumption. For design, you would create a simulation model, such as using Design Builder or Energy Plus. You would perhaps convert from Design Builder into Energy Plus, or do whatever you need to do to achieve a situation where you would get the multi-objective optimization capability. And then you would carry out the calibration of the model by minimizing errors for energy consumption. And you would do dynamic heating tests with that model to establish building physics properties such as the overall heat loss coefficient and time constant and effective capacitance of the building. And then you would move that calibrated model into the design phase, where you would again conduct multi-objective optimization until a recipe for near zero energy is achieved. And in this particular application, which is called JE+, you can, after having done thousands of simulations of parametric runs, and you've got a Pareto front, the red dots there, of optimum results, you would then hover with the cursor above the points of interest, and you would get a recipe for the design, and you would give this to the design team. And then, in terms of the quality control, you would again run dynamic tests of the calibrated model to establish the physics properties. In terms of control, reactive control results in room temperature still rising above the set temperature when the heating stops, and predictive control stops heating before set temperature is reached, and there's evidence that 20 to 35% of savings and lower ejection of solar gain is achieved with predictive control, but it requires continuous learning of building physics properties. And this particular controller is actually working. It has a predictive algorithm, and currently it is running control of my house. And it's I'm actually a guinea pig in that situation, and optimizing the control until actually it can be deployed to a wider range of buildings. Most of these things can be found in this book on designing zero carbon buildings using dynamic simulation methods, and this book is in its second edition, published by Routledge, and I would recommend it. Thank you for listening, and if there are any questions, I'm happy to answer.